Hello. Thank you very much for joining this webinar. I'm Kasumi Nagashima. I am part of the dental marketing unit of DGSHAPE Corporation. Today's topic will be milled digital dentures. Digital dentures are getting popular worldwide. As a result, more people have more questions about the workflow and tips for fabricating digital dentures. We would like to introduce our progress in the joint research project with Tokyo Medical and Dental University, which introduces our detailed workflow and tips for fabricating digital dentures. Today, we are honored to have Professor Kanazawa, Associate Professor Iwaki, Dr. Akiyama, Dr. Namano, Dr. Ki, and dental technician Ms. Hada as our speakers for this webinar. Before we get started, I would like to briefly talk about the background of this project. In 2017, we started a joint research project on milled digital dentures. Our main focus was around topics such as the accuracy of artificial teeth portion, mechanical properties of denture bases, clinical cases, and so on. With the great outcome we've seen, we are confident that our webinar to introduce the progress that we have made so far will contribute to improve the digital denture concept in general by providing workflows, tips, and advantages of milled digital dentures. In February 2022, we held a webinar in Japanese for dental medical professionals and students. We received a lot of positive feedback and requests for more information, and we thought it would be beneficial to share this webinar concept worldwide in English. Here's today's agenda. First, Professor Kanazawa will introduce the presenters from Tokyo Medical and Dental University. Then, we'll go over the workflow of milled digital dentures from impression to polishing, case report, and advantages of milled digital dentures. Lastly, Professor Kanazawa will give us the summary and provide future prospects. In this webinar, we will focus on these two milled denture solutions. On the left is a TMDU custom disc, a digital denture solution suggested by Tokyo Medical and Dental University. And on the right is our product, CADK1TR. The QR code on the upper right will take you to the product page of CADK1 and our latest product, the CADK2 series. Both solutions have one thing in common. The milled disc is prefabricated with a paramerized base with bonded artificial teeth. Details will be explained in this webinar. Okay then, let's get started. Please join me in welcoming Professor Kanazawa. Professor, thank you so much for joining us today.
Hello, everybody. My name is Manabu Kanazawa from Digital Dentistry, Tokyo Medical and Dental University. Today, we are very welcome everybody to coming to the wonderful webinar, Shape the Digital Dentures. So today I want to talk about the digital denture. First of all, I would like to say thank you to the organizer of this wonderful meeting from DGSHAPE. And today we will have a talk with my colleague from Tokyo Medical and Dental University and DGSHAPE. First of all, I would like to introduce my colleague from Tokyo Medical and Dental University. So this is my team. So her name is Tamaki Hada from Digital Dentistry. She is now research fellowship from JSPS, and she is a dental technician. She's going to talk about how to make a digital denture. And he is Dr. Yo Akiyama from Gerodontology and Oral Rehabilitation. Now he's in the PhD course, and he's a dentist. And he's an international student from Thailand. His name is Namano Sahaplom. He is from gerodontology and oral rehabilitation, and he's a dentist. And it's me, And she is Maiko Iwaki from Digital Dentistry. She's a now associate professor of my department, and she's also a dentist. And finally, she's Ki Kayok from Digital Dentist, from gerontology and oral rehabilitation. Now she's on the postgraduate student, and she's a dentist. So from all of the 6 my colleagues, we're going to talk about the digital mute denture with artificial teeth embedded custom disc. In this section, I and Dr. Ki and Dr. Namano will talk about impressions and occlusal record in digital dentures. So first, I want to talk about a denture slit scan and denture scan. About the impression of the denture slit, here is a denture slit, and we can take a scanning using the intraoral scanner. So I want to show you the video of the scanning upper jaw and lower jaw. In the case of the upper jaw, we need only one operator, and it takes just only 2 minutes. It's not so difficult. But in the case of the mandibular lower ridge, we need 2 operator, and it takes more than 5 minutes. Because for the mandibular, there is a movable mucosa, very few attached mucosa. And also there is a tongue, and also there is a saliva. So in the case of the mandibular, it is very difficult to scan. I want to show you the one case. So this patient, we can take a scan for the upper jaw, but here is 3 images. It is a mandibular jaw. We cannot scan the whole of the lower ridge at the same time. It is separated to the anterior and right side and left side. So sometimes the lower jaw may not be able to be scanned at the same time. So direct scanning of the denture ridge is very difficult. So most of the patients have a denture. So here is an existing denture. Recently, we think that scanning of the existing denture is easier. So it is a workflow of the digital denture. So here is a chair side and the laboratory side. So in the case of the chair side, we can scan the denture ridge using the intraoral scanner, and then we will make a 3D printed twine denture and get the impression body. But it is a little bit difficult. So now we are changing to this scheme. So first, we're gonna scan the existing denture using the intraoral scanner. And then we can make a 3D printed copy denture. And using the 3D printed copy denture, we can get the final impression body. So I want to explain following the one patient. So this is a patient of the photo of the patient. So here's the upper jaw and the lower jaw. And the patient have a denture. This is an existing denture. First, we're gonna make sure the jaw relationship and the border of the denture. And we decided to the denture to do the denture scanning. And then we're gonna move to the impression body. From the next session, we're gonna talk about how to make scanning and how to make a 3D printed copy denture.
My name is Qike Yu, and I'm international student from China. And now I'm PhD student of gerontology and oral rehabilitation department of Tokyo Medical and Dental University. In this section, I will describe how to scan existing denture using intraoral scanner trials. The homepage of 3Shape, which is a distributor of trials, shows that how to scan the impression of denture shape. To simplify the process of scanning the impression of denture, it should start from mucosal surface of the denture to the borders. then scan the polishing surface, and rendering process quite takes time when scanning moves from the mucosal surface of the denture to the polishing surface. Rendering is for calculation and process of scanned data. The scanning strategy what our team are applying is almost the same with the process elaborated above. But as for the scanning of maxillary denture, if we use this scanning strategy and choose the point 1 as the starting point, scanning might get a deflection, which means that the starting and finishing point cannot align and back to the correct plane appropriately. So we choose to scan the palette entirely and move side to side, and then scan the edge of denture subsequently. By the way, it's also acceptable that scanning part of the occlusal surface properly. It's unnecessary that to touch powder on the denture. During scanning from the mucosal surface to border, when scanning the vertex of denture border, which connected with the mucosal surface, it's necessary to incline the denture and scan partial polishing surface. If the mucosal and polishing surfaces do not intersect at all, the scanner cannot determine how to align the back and front side of the denture. As a result, the scanning cannot process smoothly and might take a lot of time. So based on this, it would be good if you could scan with a little concentration here. Now let me show you the actual scans. The scan mode is set as the scan only mode. At first, the scan of mandible denture, we start from the mucosal surface, then the margin scanning can include polished surfaces at the same time. And during the scanning, it might need to wait for rendering, then scan the occlusal surface. It is fine that to hold the denture in an appropriate way. Second is the scanning of maxillary denture. Scan the mucosal surface of palate by expanding the palate gradually, connecting it to the border, and then scan the border of denture. About the anterior teeth, it will be difficult due to the undercut. Please be cautious. Scan from the mucosal surface to polished surface by connecting them and scan the edge at the same time. Please secure the rendering time, and the next step is to scan from the occlusal surface to the mucosal surface of palate. During the scanning process, a warning appears in the bottom left corner, which is too many pictures have been taken, but you can just keep continuing. Because reflection of the mucosal surface of palate, this part might be a little bit difficult. Then waiting for the rendering more one time, then scanning the absent parts. Don't worry if your fingers are scanned in the interface, they can be eliminated. Finally, the dentures are scanned when they are bite. Dentures can be fit and done in an instant if there are no problems. Then check if the occlusal relationship is the same as the existing denture. If the occlusion is not correct, then either the maxillary or mandibular scan will show that the arch is distorted. If the scan is not proper, it's necessary to scan the maxillary and mandibular denture both or scan the occlusal relationship. Finally, when all scans have been completed, press post-processing button. This will automatically fix small holes. This is scanned denture. The color of completed denture is marbled for some reason, but don't worry about it. The data is the same. And here is a short summary of the scanned denture. You should use scan only mode when you scan, and please secure the rendering time. When you scan, please from the mucosal surface, and you can scan the border so that the polished surface is always partially included. And if the occlusion does not go well, just try again. Next, we will talk about how to make a 3D printed copy denture using the data from the scanned existing denture. Denture data scanned by trials is output as STL data. The data is then loaded into 3D printer software and supporters are added. Dentures can be output with 3D printer. Printer used is CaraPrint 4.0. Resin uses Dema denture-based try-in. The layer pitch was set as 100 micron. The final impression is taken using traditional impression material, so the copy denture does not need to have high precision. The supporters should be designed to attach on the mucosal surface. Printed dentures are washed and supporters are moved. And after post-polymerization by Highlight Power 3D, final finishing is completed by trimming and polishing process. And it's a summary that dentures scanned with an intraoral scan are output at STL data, and support is attached to the mucosal surface. And a stacking pitch of 100 micron is sufficient of clinical accuracy.
Hi, my name is Namano Saplom, a PhD candidate from Gerontology and Oral Rehabilitation from Tokyo Medical and Dental University. For this topic is a definitive impression and occlusal records using the 3D printed copy denture. This is an example of trying model that copy from patient existing dentures and printed from the CaraPrint 4.0 using Dema denture-based trying resin. Using 3D printing method for a copy denture is easier than using conventional method, as it only contains a couple of processes: printing, washing, curing, and cutting. In order to use the copy denture for final impression, the occlusal record evaluating the denture border morphology and occlusion of the existing denture is necessary to get a definitive denture. And I want to show you one case. First, we are trying the copy denture to make sure the fitness and jaw relation between the upper and lower denture. So in this case, we need a little more of occlusal adjustment. We made an occlusal adjustment so that the upper and lower dentures do not move during occlusion, and after this, we could make a functional impression with a static biting using the denture. For the upper jaw, we want to adjust the border. So in this case, we trim out the border 2 millimeters shortened like an individual tray using the carbide burr. Then we put the denture adhesive on the border. In this case, we want to use a silicone border molding material. And after apply the adhesive like so, dry it well. And finally, perform border molding using heavy body silicone impression material by GC company. You can see this heavy body silicone has a thick texture, and applying on overall the border, then delivery into the patient mouth. In order to inserting, be careful, do not hit the corner of the mouth when inserting, or you might distort the impression material. As I mentioned, I want to take the functional impression in a closing mouth position. So after insert the upper, then the lower afterward. The patient can bite softly. And then I ask the patient to do the functional movement like oo and ee sound and squeezing the mouth. And then separate the corner of the mouth like so. Some places are a little bit thick, so I use a scalpel cut and adjusting the thickness of the denture border. The upper figure is the before trimming, and the lower is the after trimming. After adjusting the border, we will move to the final impression. We will apply the adhesive to the resin surface, but not on the molding surface. And redone with the final impression. In this case, I use a wash impression material from GC as well. And in this case of complete denture, the impression of the border is the most important. So we need to apply the impression material over the border to the polishing surface as well. And be careful, the impression material should be applied in an appropriate layer. About 2 millimeters is fine. And insert into the patient's mouth, the same as the previous procedure. And be careful again to not touch the corner of the mouth and gently place on the upper jaw. After insert the upper, then insert the lower afterward, and ask the patient to do the functional movement for the functional impression. Now we are inserting the upper jaw with the impression material. Place it gently and then inserting the lower jaw afterward. Now the patient is bite softly, and then we ask the patient to do the functional impression again by himself. After this, so we finally finish with the upper jaw. And the same cycles were made on the lower denture as well. In this case, I think the body is already appropriate. So just only modify the border, as in this case, we don't need the border molding. And apply the adhesive all over the surface for the final impression of the lower jaw. And apply the final impression material as the same as the upper jaw. Most important point on this step is to apply an appropriate thickness of the impression material over the border to the surface, to the finishing surface. Then gently insert the lower denture followed by the upper denture. You can see we are trying to apply over the border to the finishing surface to make sure that all the border of the patient mouth is lacquered on the endural tray, like so. Now we are inserting the lower denture. Be careful again, don't touch the corner of the mouth so it will be distorted. After we insert the lower denture, and place it gently and let the patient bite softly together and ask the patient to do the functional movement again. It's like repeating as like the upper jaw. And on the figure you can see, and finally we can get the final impression of the lower jaw. And next we are gonna take the bite using the silicone bite implantation material to get the relationship between the upper and lower jaw. As you can see, I will apply the bite silicone on the occlusal surface of the lower denture and ask the patient to softly bite together. And here we have the final implantation body. In case like this that need the final implantation, you may need to do the final implantation. But actually for some cases that doesn't need the final implantation, the copy denture already fine for being a model for a final denture.
Then this section will explain how to scan impressions using a laboratory scanner. Scanner used is Shofu S-Wave Scan E3. Next stage is to select artificial teeth and gingival materials. PMMA is selected as artificial teeth, and gingival materials can be CADK12, TR, or monoblock of 3D printed custom disc. About the scan mode, object type is set as impression, and tray system is set as 2 single trays. This is model for scanning centric trays for BSS dentures, so it's necessary to manage a way of scanning. The maxilla is normally scanned with an impression body attached to a plate with utility wax. The borders should be included carefully. And the mandible is scanned when the maxillary and mandible dentures are in bite. The maxillary denture can also be scanned when fixed with the mandible denture, but it will make more difficult to fix maxillary and mandible denture together, so it is easier to scan the maxillary denture only. Once the maxillary and mandible dentures have been scanned, you will be asked to align the occlusion positions. And at this time, the maxillary denture must be scanned together with the mandible denture. Otherwise, it will not fit properly. If they are aligned, the occlusion relationship can also be aligned. And finally, the scan impression is trimmed by drawing a line around the maximum abundance, which is 4 millimeters far from the border of the normal boxing position of a normal impression body. This is then followed by the design of the denture. And when you scan, the scan mode should choose be impression as the object type, and the tray system should be 2 single trays. And when you scan the upper jaw, should scan the upper jaw only. And when it comes to lower jaw, you can scan the lower jaw when they are bite with the upper jaw. And border trimming is in the same position as a regular boxing. And that's we all talked about impressions and occlusal records in digital dentures. Thank you a lot.
Hi, I'm Yoakiyama, and this part I will introduce the final denture design and the disc design by CAD software after the occlusal record. First, let me introduce the arrangement of artifacts. If the precise impression using the digital copy denture are required to scan by a lab scanner, the impression surface can be imported in the CAD software, and it generates model subsequently. In this video, after taking a precise impression, a working model is made and scanned with a lab scanner before starting the design of the final denture. The first step is to set the anatomical point marks for both maxilla and mandible. For maxilla, marks maxillary tuberosity, the equivalent position of canine teeth, and inside the palpebral. For mandible, marks are the center, buccal side, and lingual side of the retromal part, the equivalent position of canine teeth and centric point. The pound line connects the canine equivalent of the mandible and the lingual side of the retromal part. So these 2 points should be carefully pointed. And the location of equivalent position of canine is based on the position of buccal and lingual perineum. The second step is set the border of denture base. The overall perimeter of the denture base is roughly trimmed. Then the border is exactly adjusted to the impression surface of working model. The CAD software, which is applied to fabricate the digital denture, has been reported to produce thinner and shorter borders of denture base. Therefore, when setting the border line, it's important not to draw the line at the deepest point. After the border line is established, attachment and detachment direction are determined. In the maxilla, the undercard tends to be on the labial side of the anterior crest, and in the mandible, the undercard tends to be right below the retromal part and in the posterior hyoid fossa. And the block cut can be minimized by determining the direction of attachment and detachment from the lingual side. After the determination of attachment and detachment direction, artificial teeth are arranged. First, type of artificial teeth is selected. Then the position and inclination of the dentition are corrected, and the occlusal plane is determined. The order of the teeth is from the maxillary anterior teeth, which is the maxillary central incisors, canines, and lateral incisors. Next, the molars are arranged. The molars can be moved with the 8 teeth of the maxilla and mandible while maintaining the occlusal relationship at the same time. The position of the canine teeth is used as a guide to determine the arch of the molars. At this time, the impression area and crest of the maxilla and mandible and the pound line of the mandible are used as references. The arch can be arranged approximately. After the approximate positions of the maxillary anterior teeth and the molars of maxilla and mandible are determined, the angle of teeth axis, the degree of torsion, and the occlusal relationship can be corrected one by one. And the order of correction is maxillary anterior teeth, mandibular anterior teeth, and molars of maxilla and mandible. Using the command of proximal contact or occlusal contact can simplify the processes. This part is about applied artificial teeth. At present, the available type of artificial teeth in the 3-shape dental system is quite few. From the view of disk fabrication, the current TMD custom disk requires the export of individual teeth data, while the CADK1TR requires the export of monoblock data. This difference depends on the CAM software. CAM software for TMD custom disks is currently in study processes so that disk can be completed using only monoblock data, which is the same with the case of CADK1TR. In the future, we hope that the widely available artificial teeth in Japan can be carried by 3-shape dental systems. We need to add artificial teeth that are commonly used by doctors to the system. We will introduce the method later. First, the artificial teeth is scanned from both sides of the occlusal surface, the incisor side and the basal side. These are then matched to create data for each tooth. Any scanning methods can be used, but in this case, we use a copy denture from the denture design module of 3-shape dental library. Next stage is selecting anatomy and pontic libraries from the dental systems control panel to add into the artificial teeth library. Then import the data of scanned artificial teeth, determine the orientation for each tooth. After orientation of the artificial teeth is determined, the unevenness of the base of the artificial teeth is flattened. Then the anatomical shapes of the artificial teeth are set. This process is relevant to crown bridge design because it determines the morphing point. Because this data is used only for denture design, it does not need to be considered seriously. After all settings of artificial teeth have completed, the arrangement of artificial teeth is registered in the SMILE library of the dental system control panel. It can minimize the modification during alignment if the ideal arrangement can be registered at this time. Then it's the end of adding the artificial teeth into the library. Additional supplement is unnecessary after adding. The following part is summary of artificial teeth arrangement. The benefit of digital arrangement is that it's easy to correct and adjust the arrangement. And it's easy to replace the type of artificial teeth by single click. It can also avoid the material error such as wax shrinkage. One of the differences from analog is that the 3-dimensional structure is checked on a flat screen, and the work is done at a higher magnification than the real thing, so there is a gap between the design and the actual output. Therefore, it is important to check the design from various angles and grasp the whole situation when changing the magnification ratio to the same size as the real thing. Next, I will discuss about gingival formation. There are several initial templates available, but we haven't done the whole processes without any modification, so it's acceptable to choose any of them. However, we should pay attention to the thickness of maxillary plates specifically, and the minimum thickness should be set at 1.5 to 2 millimeters. In most cases, we start with insufficient gingival volume and add complementary gingiva to the necessary areas subsequently. Then smoothing is done to achieve the appropriate shape. It depends on the size of the milling bar used, but be aware that if the interdental papilla are set too finely, milling may not be possible. Basically, the work proceeds without changing of the mucosal surface, but the modification of the border of denture base and the postdam should be implemented in the mode of our modification. This part will be described later. There is one point that, especially for the forming of gingiva, the work time can be greatly reduced by using shortcut keys. So please try using them. This part about the border of denture base. Lee et al. Reported that the denture-based borders designed in CAD software can be shorter and thinner. They also reported one way to address this issue, which is matching the data of definitive denture design in CAD software with the data of the original impression from which the border formation was made and correcting the data of the border of denture base. Although the method is not always necessary, it's necessary to master the trend of CAD software. Therefore, the border of denture base should be revoked while checking the working model or impression. This part is about post-dump. The post-dump should be decided by the doctor in charge according to each case. From the view of design, the GG method is easier when the design is started by scanning the impression without making a working model. This is because that, as mentioned above, it's allowed to make some modification of mucosa surface, but when the Swenson method is applied, it may affect the posterior border of the denture and the polished surface. If working model is fabricated, any method is acceptable because the scan can be performed after digging a post-dump or on the model. The most obvious benefit of digital gingival formation is that you can easily return to the previous work by Command plus Z. Due to the simpleness of correcting the error, it's acceptable to design freely. It's better to add a lot of things and smooth them out over a wide area than add many details gradually. One difference from analog is that it's impossible to tap and feel the slight unevenness by hands. Therefore, the output may be more uneven than expected. It's not necessary to confirm the morphology from various angles and 2D cross-sections during the design process. In the early stage of designing, it's also helpful to compare the output denture with the screen during the design process to confirm how the differences, how the denture was represented in the CAD software, so that the digital design can be done more quickly. Next part is about framework design. In the current research, TMD custom disks are designed using general CAD. The framework which can apply for milling machine is designed in advance. Because the TMD custom disks are designed by us, it allows the modification of height of the framework within the limit allowed by the milling machine, and an internal support structure can be added to provide a structure that resists shrinkage of toward the resin. When positioning an artificial teeth in a socket, if the socket is given with the actual size of artificial teeth, the return of the artificial teeth is not good, and errors may occur during milling. Therefore, the socket of the artificial teeth should be set slightly larger than the actual size of the artificial teeth. Specifically, 0.2 millimeter in large space than the final denture is designed. This kind of design artificial teeth are positioned in the design framework. The intersected parts of design outer framework and the artificial teeth and resin denture base are removed from the disc to complete the design of the framework. Do not forget to check that the denture does not protrude from the framework. Dentures that are larger than a framework may not be suitable, but we have no experience with such cases until now. Due to the difference of framework, from the view of design, the timing of designing the socket of artificial teeth is different. Currently, TMD custom disks are produced by a 3D printer with a frame that has sockets for the artificial teeth in the CAD software. On the other hand, CADK1TR is uses CAM software to design the artificial teeth socket and mills the prefabricated frames to provide the artificial teeth socket. Later, we'll introduce the details. This is a summary of the results so far. It's more efficient to start with a rough outline of the artificial teeth and the gingiva, and gradually proceeded to more detailed part of the artificial teeth. For all processes, it's necessary to check them from different angles. These are all my presentation on the design of final denture and disc by CAD software. Thank you so much.
Hi, my name is Tamaki Hada from Digital Dentistry in Tokyo Medical and Dental University. Next, I will introduce the production of TMD custom disc and disc using CAD-CAM. First, I will explain the differences between the two methods. In the TMD custom disc method, as Dr. Akiyama explained, the framework data of the custom disc designed with CAD software is output to a 3D printer and printed with photopolymer resin. Therefore, the artificial teeth socket position is completed with a print, so there is no need for additional processing later on. This method has been published by Dr. Soeda in TMDU. On the other hand, CAD-CAM is a prefabricated tray sold by DGSHAPE. This tray is set in the milling machine and the artificial tooth socket is milled. The differences between the two methods are the artificial material used for the framework or tray fabrication and the related machine. Next, I would like to talk about the points of the printing of the framework and artificial tooth socket milling. After the STL data of the designed framework is prepared, it is output the 3D printer software, and the parameters such as the printing pitch and direction are set in the software. For the printing pitch, we recommended 0.1 mm, which we have been able to print efficiently without any accuracy problems. In addition, we recommended printing at an angle of 45 to 90 degrees. Because there are many print failures during printing when the framework was 0 degrees. In this video, the framework is set at 45 degrees. Once the angle has been determined, supports are added. In these cases, we selected the mode that automatically generated the support. Once the support is generated, send the data to the 3D printer and start printing. After printing is finished, the framework is cleaned with isopropyl alcohol, dried, and post-cured. The support should be cut after post-curing to prevent deformation due to polymerization. This slide shows a side view and a top view of the printer platform. The formula of the Form 3 printer used in this study has a build capacity of 145 mm and 145 mm and 185 mm, which is a very large platform for SLA type printer. As shown on the left, when printing at 45 degrees, a framework with the highest accuracy can be printed. On the other hand, as shown on the right, when printing at 90 degrees, a maximum of 2 frameworks can be printed at a time. From the above, 90 degrees is recommended to shorten the printing time and print more efficiently. If you print with a large number of framework supports, the print time will be longer. Therefore, it is possible to reduce the density of samples to shorten the printing time. Once the SLA data, SDR data of the framework is completed, set the parameters of your 3D printer software appropriately in order to print the framework efficiently. The photopolymer resin used to reduce the framework will be milled after the final printing and will not actually long time applied in the oral. So any type of photopolymer resin for printers can be used. Next, we will introduce artificial teeth socket milling using a prefabricated plastic tray, CA available for DGSHAPE. This tray is milled with DGSHAPE's milling machine before milling the artificial teeth socket. Two different thickness bars are used for milling to reduce the occlusive surface of the prosthesis to the finest detail. The milling time is only about 1 hour per denture base, and the tray with the artificial tooth socket can be completed in relatively short time. Trays for large dentures are also available. Mr. Inu will introduce these large trays later. Next, I would like to introduce the two types of prefabricated artificial tooth arrangement. The procedure from the arrangement to the completion of the prosthesis is almost the same in both cases. After sandblasting the base surface of the artificial teeth, it is fixed to the framework or tray with cyanoacrylate glue. Since the artificial teeth are always stuck in a certain position, the adhesive must be carefully poured to prevent its misalignment. In particular, because the contact area of the anterior mandible is smaller than that of the molars, it is difficult to determine the fixation position and requires some practice. In common with the method, as long as you have the data of the prefabricated artificial teeth you want to use for the actual denture when designing the denture data, you can use artificial teeth of any materials from any manufacturer, such as hard resin to a ceramic teeth. The following is an introduction to the pouring the auto-polymerizing resin. After the artificial teeth are aligned, the denture-based resin for both dentures is poured into the framework or tray. Then, after heat and pressure for polymerizing, the discs are cold or room temperature to complete the process. The specific curing procedure is shown in the video of TMD custom disc fabrication. First, an adhesive agent is applied to the base surface of the artificial teeth to chemically bond to the artificial teeth to the denture-based resin. We measure the poured resin liquid and the powder according to the manufacturer's instructions. We use Shawfood's auto-polymerizing resin, fit resin. Mix the resin without bubbling. The resin is poured in a long, thin stream to avoid bubbles as much as possible. The resin is poured until the surface tension is generated, considering the polymerization shrinkage. When the surface of the resin becomes matte, press it gently the pressurizer. The polymerization situation includes the polymerizer is set at 0.3 megapascal and the water in the room temperature. The polymerization is completed and the disc is ready when it is left at room temperature. In this way, a custom disc with an artificial teeth is made for each patient. Summary. TMD custom discs are fabricated by a 3D printer using photopolymer resin for the framework, and a maximum of 2 discs can be produced per 10 hours of printing time. The CADK1TL used a tray and a milling machine to cut an artificial tooth socket. Cyanoacrylate glue is used for bonding the artificial teeth. The resin is poured until surface tension is generated. The resin is poured into the pressure-induced pot when the surface of the resin becomes matte.
Thank you, Ms. Hadar, for your introduction on how to create the discs. From here, I, Inui, from DGSHAPE Corporation, will review the process of milling and the compression of the denture. We will start with the milling process using our DWX dry devices. Then we will introduce TMDU's research results on the accuracy of the teeth position and the mechanical properties. Finally, go over the process from polishing to compression. This will be our agenda for this section. We will start with reviewing each CAM software compatible with the CADK1TR and TMDU custom disks and the detailed process. Then we will take a look at the requirements for milling and introduce the parts that DGSHAPE developed specifically for denture milling. Finally, we will cover the process from setting the material and parts to starting the milling. On the left side, you will find compatible CAM for the CADK1TR, the popular dental CAM software capable of all kinds of application. Millbox, a product of SIM system. DGSHAPE Dental CAM is dedicated to denture or model production, and we can offer a lower price. So if you don't have a Millbox already, you can use the CADK1TR solution with DGSHAPE Dental CAM. The right side shows compatible CAM for the TMDU custom disk. Actually, the TMDU custom disk is not distributed in the market yet. Therefore, the word compatible may be inaccurate. We have used a special version provided by SIM system for our research purposes. However, as Professor Kanazawa and his team have introduced today, the TMDU custom disk is a very attractive solution from a clinical point of view. We understand that TMDU will continue the research to improve their solution and also work on CAM software such as Millbox and DGSHAPE Dental CAM for compatibility. Now, let's take a look at the steps of creating a CAM file. We will take the CADK1TR solution as an example, as the TMDU solution is still under development. The workflow for the CADK1TR are on the right side. For comparison, the workflow for the CADK1 solution for denture-based production are on the left side. The process using Millbox and using DGSHAPE Dental CAM are identical. While there are 6 steps for the CADK1, the CADK1TR has 7 steps. The preparation time is about 5 minutes with either solution, and the total time required to generate a milling file is around 20 minutes for the CADK1 and 30 minutes for the CADK1TR. The CADK1TR can generate files while accurately subtracting or adjusting the positional information of the teeth sockets and the base portion respectively, so that these 2 types of files can be generated automatically and continuously. As a result, the CAM flow is kept efficient, requiring only about 5 minutes of operation time, despite the special workflow. With including the CAM file, there are 7 components required for milling the TMDU custom disk and 8 for milling CADK1TR. CADK1TR requires the special jig number 5, a DWX milling machine, milling bars, a material, an adapter, a special jig for CADK1TR, V panel, a CAM file, and an extractor are these components. Now, I would like to introduce the 4 milling bars we developed specifically for denture milling. The bar on the leftmost is a 3 mm roughing bar that can significantly reduce milling time. And each ZPB bar has a durability of 80 hours for PMMA milling. Although the number of dentures these bars can mill varies according to the size, each bar is durable equivalently to milling the number of dentures as shown in the chart. Now, we need to properly set the materials and bars. The CADK1TR material, the cured blocks you have prepared, must be attached to the adapter and the special jig before mounting into the machine. The special jig is not necessary for the TMDU custom disc material. The bars need to be set in the proper position accordingly with the guide on the CAM screen. Our disk changer models, DWX52DC and DWX52DCI, are capable of automatically changing up to 6 disks, enabling consecutive and unattended milling. Once we have finished the preparation of CAM files, the material and bars, we can drag and drop the CAM file into vPanel and start milling. As I mentioned before, we can cool up to 6 files in vPanel when using a disk changer model. This will be all for the overview of the milling process with the DWX machines. Thank you for your kind attention.
Hello again, I'm Tamaki Hada. Next, I would like to introduce the results of our research team, the accuracy of teeth position and mechanical properties of denture base fabricated by different systems. Here are the results of the accuracy of artificial teeth position on the TMDU custom disc and the CADK1TR. In this study, a milled disc with 12 teeth concentrically aligned for 3 types was photographed by cone beam CT, and STL data was prepared for the artificial teeth part only. The milled artificial teeth and the master data was superimposed to obtain the degree of accuracy, and the milled artificial teeth were superimposed each other to obtain the repeatability. The result of deviation analysis and calculation of mean absolute error, which is one of the error indicates, and so in the table. The result of the comparison of the positional accuracy between the TMDU custom disc and the CADK1TR showed that the error was less than 0.1 millimeter for both discs in all teeth types, which is within the acceptable range in clinic. The result of the comparison of the mechanical properties of the custom CAD/CAM block fabricated by pouring a commercially available autopolymerizing resin into CADK1 compared with those of the commercially available CAD/CAM disc and the conventional heat polymerizing resin. All the materials meet the requirements of ISO standard in the 3-point bending test, water sorption and solubility test, and discoloration test. Based on all the results, the custom block for CAD/CAM made by pouring commercially available autopolymerizing resin into CADK1 was considered to have mechanical properties within the acceptable range for clinical use. Finally, the process from polishing to completion of the denture presented. After milling, both dentures are cut with a fisher bar to cut the supports that are holding denture in place so that it would not fall out. The cut portion of the support is cut with a carbide bar until it does not hurt when touched with a finger. After milling, the nailed area is polished with big point. After milling, only rough polishing is sufficient for the nail surface. Buffing takes about 10 minutes for the upper and the lower dentures combined. Summary: the accuracy and mechanical properties of both types of disc are within the acceptable clinical range and can be used reliably. After milling the disc, the support is cut off with a fisher bar to remove the denture from the disc, and the support is cut, polished, and buffed to a fine finish. Since the denture surface is very clean after milling, the total polishing time for the upper and lower dentures is about 10 minutes, which is shorter than that of the conventional methods. Thank you for your attention.
Ms. Hadar, thank you very much for your presentation. Hello again, everyone. In this section, let me change the topic and introduce our new denture kit solution, CADK2. Firstly, I have a short video for you. See you in 3 minutes. How about the video? This is the CADK2 series we released recently. We developed it for larger size denture production to overcome the size limitations with the CADK1 series. We are very grateful for introducing the CADK2 series in such a fortunate opportunity with TMDU intellectuals. The explanation contents are as follows. Firstly, we will review the expanded size and the compatible materials. Then, we will go over the workflows and compatible CAD/CAM software and milling machines. Lastly, I'd like to summarize the lineup of our CADK series. The expanded size is one of the most remarkable updates in the CADK2 series. CADK1TR can produce average-sized dentures for Japanese patients' mouths, but some cases outside of Japan required larger sizes which could not be fitted into the CADK1TR. The CADK2 solution can fit in these larger cases. We confirmed the expanded size could produce almost all sized dentures based on feedback provided from 88 cases of TMDU. However, the cost of acrylic resins and milling bars for the CADK2 series would become higher than that for the CADK1 series, as the expanded size requires more acrylic resin and milling. So we recommend to use the CADK1 series for normal size dentures and the CADK2 series for larger size dentures if necessary. Material for digital dentures is one of the commonly asked questions when discussing digital dentures. With the CADK series, we can use both cold and heat-cured acrylics that are already distributed in the market. The CADK1TR is compatible only with cold-cured acrylics due to bubbling issues, which we will cover later. However, we have improved the workflow with the CADK2 and resolved these issues. Regarding the compatible artificial teeth, we can use existing products with the CADK2 as we can with the CADK1 series. Now, we will move to our next topic, the workflow of the CADK2 series. I will start with the workflow for cold-cured acrylics. The workflow is the same as the CADK1 series, except that we use a different tray and the special jig is unnecessary. As shown above, the workflow with the CADK2 FX is the same as with the CADK1. First, pour and polymerize the acrylic with the CADK2 FX tray, mill only the gingival part, and then manually press artificial teeth and polish. On the other hand, as shown below, the workflow with CADK2TR is the same as the CADK1TR. First, mill the teeth sockets on the CADK2TR tray, manually press the artificial teeth before pouring the acrylic, polymerize, and then mill out the full denture. Let's move to our next topic, the workflow for heat-cured acrylics. Basically, it is the same as the workflow with cold-cured acrylics. However, we need two additional steps to resolve the issue of bubbles that occur during polymerization. The two additional steps are: 1. Mill a small hole in the center of the tray to emit the bubbles, and 2. Place the tray on the dedicated breathable silicone stand during polymerization. These two steps create the outlet for bubbles from the bottom, not only from the top. This will not increase the milling time and running cost much, as it only takes about 5 minutes to mill the small hole, and we can use the silicone stand repeatedly. Now, let's take a look at software and milling. Compatible CAD/CAM software and milling machines are the same as the CADK1TR. For CAD, we can use the denture design module of 3Shape CAD and the full denture module of ExoCAD. Regarding CAM, we can use Millbox and DGSHAPE dental CAM. Finally, for milling machines, we can use DWX dry machines, DWX52D, DWX52DC, and DWX52DCI. To summarize, I would like to review our lineup of the CADK series. There are 4 kinds of solutions to choose from according to your preferred workflow and the size of denture to be milled. As I have demonstrated today, the solutions that can mill the entire denture, both the teeth and base part, are the CADK1TR and CADK2TR. On the other hand, the CADK1 and the CADK2FX only mill the base part, therefore the teeth must be replaced after the milling. We are confident that you will find your choice for starting digital dentures. That's it for the introduction of the CADK2. Thank you for your kind attention.
Next, I would like to introduce the case report of the CADK2TR prototype. This is the patient information. The patient was a 74-year-old man, and the current dentures were made by me using the conventional method. Since the occlusal surface of the current denture was significantly worn, we decided to manufacture a new one. Regarding the production of dentures using the CADK2TR prototype, we started to production of the new set of denture with the consent from the patient. And there were no medical history interference the denture treatment. The current prosthetics was scanned using an E3 scanner on the day of the first treatment. By the time of the next visit, I made a copy denture using a 3D printer. I used a Form 3 printer from Formlab company and used the dental surgical guide resin. The support for 3D printing is set to attach on the finishing surfaces. The picture you are looking at is a comparison between the existing denture and a copy denture. But the copy denture are made with a very high degree of reproducibility. So you can see a similarity feature compared to the existing denture. Also, what I did to make a copy denture was only to scan from the current dentures, clean and post-polymerize after 3D printing, and remove the support, which is easier than the conventional denture. Then it is time to check the comforting of the denture. The upper photo is the one immediately after applying the mucosal compatibility test material or DentSport, and the lower denture and the lower photo is when immediately after trying and place the denture inside the oral cavity with finger pressure. The part pressure on the mucous membrane was found, including the support residue not from the 3D printer, but the fit was generally good. The part where the DentSport came off was adjusted and so that there was no pressurized part when finger places. Next, I needed to confirm the occlusal relationship. The occlusal paper was marked on the left and the right molars, but strong contact were also found on the anterior parts. Adjustments were made so that the left and the right molars occlude evenly. And next, the denture edge was evaluated using the silicone type mucosal compatibility test material or fit checker. As a result, from the denture borders evaluations, it was found that the distal border were insufficient on both the upper and lower denture. So the border was formed using a border type silicone impression material. After the border formation was completed using the border type silicone impression material, a precision impression or functional impression was taken using washed silicone impression material. Functional impressions were taken from the upper denture first, and the lower jaw were taken secondly. The functional movement at the time of border molding was performed by the patient's own movement. The occlusal record was performed using the biting silicone. Regarding the occlusal height, it was thought that the occlusal height would be raised by the thickness of the silicone implantation material on the mucosal surface from both the upper and lower dentures, and the biting silicone material for occlusal record as well. However, the slightly raised occlusal height is appropriate because occlusal wear was observed on the occlusal surface of the existing denture, and there were no problem with facial feature after taking an impression, pronunciation, and functional movement of the swallowing. I decided that since there was no aesthetic requirement for the existing denture, we confirmed with the patient that we would proceed with the production of the new prosthetic without changing any arrangement position of the anterior teeth, including the lip support. If the patient is aesthetically dissatisfied with the existing denture, we will modify the existing denture before the scanning to eliminate the aesthetic dissatisfaction, or adjust the lip support and incisional edges. If adjustments are made at the time of trial fitting of the anterior teeth, it is recommended to perform trial fitting again. And here is the differences between each dish. The CA-DK2TR has a dish height of 35 millimeters, and it is possible to manufacture relatively large all surface of the dentures. We have confirmed that the artificial tooth in this case did not fit on the disc with the CA-DK1TR. It is necessary to select an appropriate disc according to the cases. There are new dentures after the milling is completed without any trouble such as broken bar during the milling. No uncut or excessive cutting was found on the mucosal on. No uncut and excessive cutting was found on the mucosal and occlusal surfaces. The milling time per denture was about 4 hours each. In this case, artificial hard resin tooth and a liquid denture-based resin were used to make a new denture. The morphology collection after the support was removed has done accordingly to the patient mouth. The accuracy from the milling machine was high, and the time required for morphological collection was particularly short. And the polishing was also done using the straight type burrs as usual. This is the adjustment state of the mucosal surface when the new denture are trying on the patient. The upper photo is the one immediately after applying the mucosal compatibility test material or Densport, and the lower photo is the one immediately after with the finger pressure on the ridge. The fit was relatively good, but the contact was observed near the incisal papilla of the upper denture, the apex of the ridge of the left side of the lower jaw, and the muscle line on the right side. This is a comparison between the photograph immediately after applying the mucosal compatibility test material or Densport and pressurizing the finger pressure, and the photograph of the impression material of the time of when obtaining a precise impression. On the mucosal surface of the new denture, a strong contact pressure was observed on the part where the silicone impression material was removed, and the tray resin was exposed at the time of the impression. From these photographs, we can see the high reproducibility of the new denture. We adjust the part that came into strong contact with the mucous membrane. And this is an occlusal contact state Immediately after, the pain disappeared due to the finger pressure after adjusting the mucosal surfaces. Occlusal contact can be seen in the molars and anterior teeth on both sides. The left side touch slightly stronger than the right side, but the amount of occlusal adjustment was very small. The cause of the slight strong contact on the left side was thought to be an error when implanting the bite occlusion. And in addition, in the conventional heat polymerized resin filling method, the position of the artificial tooth is displaced due to the shrinking of the resin. And it is often experienced that the small molar teeth are in strong contact. In this case, the molar teeth were in contact, and the result was very close to the design occlusal contact state as determined. And finally, these are the facial appearance of the patients. The occlusal height of the new denture was slightly raised comparing to the current one, but it seemed to be within the permissible range, and it was considered that the arrangement position was in harmony with the facial appearance. In addition, there was no problem with pronunciation and swallowing movement. And also the patient also said, I used a lot of complete dentition so far, but this time I use it and it's fit immediately. In short summary, it has been reported that the new denture has better fit accuracy than on the tissue surface and less misalignment on the artificial teeth than conventional complete denture. And in this case as well, it is suggested that the fitting accuracy of the tissue surface and misalignment of the artificial tooth are small. In this case, the primary scan was initiated on the day of the patient's consent on the new denture treatment. The new denture was deliberately at only 3 visits, while the conventional method required 5 to 6 visits, and it is considered that the milling method does not burden the patient time. In this case, we do not make a plaster model, but complete the denture with a full digital workflow. And the CADK2TR disc is a disc with a height of 35 millimeters, and is considered to be applicable to most cases. And heat killing resin can also be applied, which means more option of material. This conclude the presentation of the case using the CADK2TR prototype. Thank you for your attention.
I'm Michael Iwaki, Associate Professor in Digital Dentistry. In this section, I'd like to talk about the advantages of the custom disc method in the following 3 sections. First, I'll show you the difference between DGSHAPE CADK1TR and TMDU custom discs in the custom disc method. During the presentation, CADK1TR will be called TR. The upper section shows the fabrication flow of the TMDU custom disc, and the lower section shows the flow of the TR. The process of designing the denture is exactly the same. The biggest difference is whether a 3D printer or milling machine is used to make the framework of the custom disc with the artificial teeth socket on it. The step after the completion of the custom disc framework, that is the step of aligning the artificial teeth according to the artificial teeth sockets, injecting the resin for the denture base, and polymerizing the resin are exactly the same. And thus, the completed custom disc is almost the same shape. As Ms. Hada has already shown that the positioning accuracy of both of these discs is excellent. The cost of material and the consumable are shown here. There is a difference whether the first step of the framework publication is done by CAD or CAM. However, the price of the light curing resin for the 3D printer and the price of the trays for the TR are almost the same per denture. In addition, the cost of the artificial teeth and the resin for the denture base varies depending on the type, which is the same for both. Therefore, the total cost can be considered to be the same for both types. Now that I have talked about TR and TMDU custom disk, I'd like to introduce a clinical study conducted at Tokyo Medical and Dental University Hospital, in which 20 patients actually received a complete denture using TMDU custom disk and evidence in the paper. This is an outline and flowchart of our clinical study in which 20 edentulous patients had their upper and lower complete dentures fabricated with TMDU custom disks, starting with optical impression using an intraoral scanner, and the clinical efficacy of the custom disk method was evaluated with patient satisfaction and cost effectiveness as the primary outcomes. This is a prospective study. The following is a detailed flow of one of the cases. Here are the oral and facial pictures at the initial examination. The maxillary ridge had a strong undercut, and the mandibular ridge was resolved in the molars with only the anterior teeth remaining. This is a picture of existing denture at the initial examination. The denture was transferred from a partial denture and had been used for many years. In the first visit, we scanned the upper and lower jaw ridge using an intraoral scanner and then scanned the occlusal record using a silicone pate jig. By combining this data, the relationship between the patient upper and lower jaw can be reproduced on a PC. However, the optical impression data is not yet accurate enough to fabricate the definitive denture, and a trial denture and trying denture design is needed. A 3D printer was used to fabricate the 3D printed trying denture. This denture has all anterior and posterior teeth in the upper jaw and only anterior teeth in the lower jaw, with a flat occlusal ridge design on the molars. By using the trying denture, it was possible to take accurate impression of the upper and lower jaw ridge using silicone impression material. Try on the anterior teeth and record the jaw relationship at the same time as its conventional method. The impression brought back from the chair side were scanned up and lower at the same time using a 5-axis labo scanner to acquire STL data. At that time, we used a labo scanner called New-Way, but now we often use a 3-shape scanner. From these data, we used the universal software, Mimics, and Freeform to design the definitive denture. The denture designs for the 20 cases in this study were performed by dentists and dental technicians in our team. Then, Custom discs were fabricated and denture were milled. In this clinical study, all 20 cases were milled using the DWX51D. Here is the completed denture. This is a picture of the denture delivered in the patient mouth after the third visit. The denture fits well and the occlusal condition is stable. So the patient can use the denture without any problem after a short adjustment. And here is a paper that Dr. Otake in our team had accepted for publication in the Journal of Prosthetic Dentistry in last year, which summarizes the result of this clinical study on patient satisfaction and cost. The red bar indicated a significant increase in satisfaction with the custom disc method compared to the conventional method for existing dentures, as indicated by the gray bar. In terms of cost, the custom disc method may at first look expensive. However, after analyzing the cost materials, equipment, labor, and total cost, the TMDU custom disc method reduced the cost of clinical materials and the labor cost of dental technicians, resulting in a lower total cost than the conventional method. As a result, the total cost was also lower. Therefore, this study indicates that the custom disc method can improve patient satisfaction and cost effectiveness compared to the conventional method. In 2021, Professor Murari of the University of Zurich published a review paper comparing milled denture, 3D printed denture, and conventional denture. In this paper, a meta-analysis of 73 previous articles on digital dentures shows that milled denture is not only superior to conventional and 3D printed denture in terms of various mechanical and surface properties of materials, but also in terms of patient-reported outcome, chair time, cost of laboratory work, and total cost by the result of clinical studies. From the above, the advantage of the custom disc method can be summarized. The advantage of the custom disc method in milled denture includes the use of TMDU custom discs and TLs. The custom discs have the advantage of the following. The disc can be designed flexibly, which reduces the amount of resin used. The disc does not occupy a milling machine, and the free time of the 3D printer can be utilized. On the other hand, the TL has following advantages. Disc fabrication is easy to operate because the discs are fabricated. NC data can be created quickly using template when creating artificial teeth sockets, and a single milling machine, DWX series, can be used even if the user does not have a 3D printer. The common advantage of these custom discs are good accuracy of the denture mucosa surface without the influence of polymerization shrinkage. Use of various prefabricated artificial teeth, high adhesive strengths between the artificial teeth and denture base, saving materials and the time during milling, customized occlusal surface for each patient, and so on. Finally, a summary of this part. The custom disk method includes the use of TMDU custom disk and TLs. And it is effective to use different methods depending on the case and the machine used. In both cases, the definitive denture is a DWX series mill denture, which has been shown to have better accuracy and mechanical properties than the conventional method, and has been clinically evaluated as well. It's finished my part. Thank you for your kind attention.
Hello again, I'm Manabu Kanazawa. I would like to summarize this webinar. So I want to talk about the summary and also future prospect. So here is the cost effectiveness of the digital denture. So x-axis, you can see the cost, and y-axis is the quality. Today, I talked about the milled denture with custom disk. As we said, custom disk have a high quality comparing to the conventional denture. And also maybe milled denture have a high cost. And here is today I didn't talk about the milled denture with bonded teeth, but in the case of the bonded teeth, quality of the denture is a little bit lower than milled denture with custom disk. And today also we didn't talk about the 3D printed denture, but so there is so many research about the 3D printed denture, and they prove that the 3D printed denture have a low cost and a little bit low quality. But this is a very fast, and this denture have a reproductivity. So there is a 3 kind of the digital denture, but you can choose every solutions depending on your situation. If dentist and the patient require high performance denture, you can choose a milled denture with custom disk. And today I want to talk about the summary of this webinar. So about the denture switch scanning and denture scanning. So comparing to these 2 scan method, the denture scan by intraoral scanner is easier. And then you can fabricate digital 3D printed copy denture. And next, you can print out the 3D printed copy denture. So in this time, when you scan the existing denture, prepare the sufficient rendering time between scanning of the mucosal surface and polished surface. In the background, the intraoral scanner is fabricating the 3D data. So we have to take a time. And when we scan the border, first you're gonna scan the mucosal surface, but scanning of the border, you have to scan mucosal surface and also polished surface at the same time. And when you use a 3D printer, layer thickness set as 100 micrometer is adequate. So I'm gonna move to the design. So about the arrangement of the artificial teeth. First, you're gonna make a hole of the denture, and next move to the teeth. And about the gingiva, put the high volume of the gingiva, and then you're gonna trim and adjust it. And the design was a framework, so you can set the artificial teeth into the socket, and also the denture will be within the framework. Sometimes the denture border, or in the case of the lower jaw, the lateral part is coming out of the framework. So make sure that every denture is within the framework. Next is a fabrication of the custom disk. So TMDU custom disk, we can fabricate this framework by 3D printer. And next is the CA DK1TL. In this case, the socket of the artificial teeth is milled by the milling machine. And in the both of the two methods, when we pour the resin have a shrinkage during the polymerization. So pour the resin until the surface tension is generated. And put this custom disc into the pressure pot when the surface resin is getting matte. Next is about the method of the custom disc. So as we said, there are two kinds of the custom disc. One is a TMDU custom disc, and next one is a CADK1TL, CADK2TL. So we can select the two methods depending on the situation. But both of the two discs show the high accuracy, high mechanical property, and high patient satisfaction. So it's a summary of the milled denture using the custom disc. So this denture have a high accuracy because of its milling, and there is a high adhesion between the artificial teeth to denture brace. And you can use any prefabricated artificial teeth, and also prefabricated artificial teeth have a high aesthetics. And also you can customize the occlusal scheme like a linearized occlusion and full balance occlusion, depending on your preference. About the laboratory work, we can reduce the working time, and we can provide the very clean environment comparing to the conventional dentures. And about the quality and the cost, so we can provide the quality control of denture. And this system shows a high cost effectiveness. So that's everything what we want to talk. So this is a picture of my colleagues. So today I talk about the future of the digital denture, but it's not the future. It's a very, very near future. Now you can get this digital denture. We hope your clinic, this webinar will help your future denture clinics. Thank you very much for your kind attention. Thank you so much.
Thank you very much, Professor Kanazawa, Associate Professor Iwaki, Dr. Akiyama, Dr. Namano, Dr. Ki, and Dental Technician Ms. Hara. We have covered all topics for our webinar today. Please visit our social media channels in Facebook, Instagram, LinkedIn, and YouTube for further information. And I would like to thank everyone for joining us today for this webinar. I hope the information we share today will help you in your practice or in your labs. Thank you and have a wonderful day.